It is impossible to imagine today's production floor without robots. Yet programming robots is often a difficult and complex process, especially in applications such as plate bending, welding, polishing, and laser cutting. Robotic motion systems require programming with a considerable degree of freedom. Current methods involve a lot of manual tuning and programming and are often suboptimal in speed and productivity. At Flanders Make, we've developed a toolchain to support a robot programming engineer in the different steps of specifying and deploying control-based robot programs. We demonstrate this technology on a bin-picking task. Through an intuitive GUI, the engineer can visualize the robot's working environment and change certain parameters of the task. Next, the robot program will be updated on the fly for different locations of the bins and obstacles and automatically recompute motion plans. Using this toolchain vastly reduces the complexity of computing optimal robot motion plans and speeds up the deployment time. It offers programming engineers a lot of flexibility and efficiency gains. They only need to enter the size and locations of the bin and obstacles through a GUI, and collision-free robot motions are generated automatically without having to manually set waypoints. Also, as the computed path is optimal, robot motions are much smoother and faster, resulting in efficiency gains of at least 30% over the current state of the practice.